Oops, wrong way. All right, hold on a second. I got to get this thing to refocus. All right, so we're going to talk about derivatives of inverse trig functions. So let's take a look at one of these guys. So let's say I want to find the derivative of y equals inverse cosine of x. So find dy dx. I'll use the Leibniz notation this time. Okay. So right now, like we can do the derivative of cosine, but we don't really have any kind of formula we can apply directly to inverse cosine. Okay? So we're going to kind of do a backdoor approach to the derivative of this one then. So if y equals the inverse cosine of x, think about what an inverse cosine really is. What is x equal to then? If y is the inverse cosine of x. Right? Isn't that how we define inverse cosine? Yeah. An inverse is where x and y would swap, right? So instead of y equals cosine x, it's x equals cosine y. These are really equivalent statements. They mean the same thing. Okay? So, x equals cosine y. Can we do the derivative of that? Sure. Using implicit differentiation, right? Because the y now is in the cosine, but it still works, okay? We can still do that. So, let's try that real quick. So, derivative of x, 1. Derivative of cosine, negative sine y, and then don't forget your y prime. Okay, so what we can do there then is we can then solve this thing for y prime, just like we're used to doing. So y prime becomes negative 1 divided by sine y. Okay, that's nice, but I really wanted a derivative of y where I'd have x in my answer somehow, right? Right now I've got a derivative that's got a y in it. So then the question becomes, all right, so how can I take care of that? Okay, well, we have a identity that involves sine and cosine. Okay, and so we're going to pull this back out for a moment. Okay, so I'll remember that one. Cosine squared, and I'm just going to use y this time just because it's convenient for what I'm doing. So cosine squared y plus sine squared y equals 1. Okay, so take a minute, take that equation, that identity I just gave you, and solve it for sine y. Think you can do that? Solve it for sine y. Or I'm sorry. No, I'm right. Solve it for sine y. Yeah. So did you say that? Yes. Then yes. Then you're right. Yep. So 1 minus cosine squared, and then you got to square root the whole thing, right? Okay. So take this, since it's equal to sine y, and put it in and substitute it down here into this one. I know, you're all going to be like, what the heck are you doing? This is not any better, Mr. Herrick, but just trust me. Do you? Oh, that's good. Okay, so how in the world is that any better? Well, focus your attention up here if you would. X is equal to cosine y. I make a little substitution there one more time. And we got something, right? So y prime is equal to negative 1 over the square root of 1 minus x squared. I've got a derivative formula for this thing. It's pretty nasty looking, but it works. Okay. So I had to go through implicit differentiation, a Pythagorean identity, and a couple of substitutions, but I got something. I got a derivative for this, and this is a function, right? What I began with. So I took this function, and I got a derivative just in terms of x that'll work for it. Okay? So what I'd like you to do is repeat this process on your own real quick. Take about 5 minutes for inverse sine. See if you can get a derivative for inverse sine doing the same technique we just did. Thank you. All right, if you're not done yet, don't look at the board. If you are, do look at the board so you can check and see how you did. They're nearly identical, right? The only difference is the derivative of inverse cosine is negative and the derivative of inverse sine is positive. Okay. Okay, now, the other 4 trig functions, you can do the same kind of process with those and get the same kind of answers, that sort of thing. I'm just going to write them all down so we don't have to spend the time to do that, okay? So, please write these down. It's very, very important because you're going to need all of these in your assignment. And it's being able to use these effectively is going to be the challenge in what we're doing today. So inverse tangent, that derivative is 1 over 1 plus x squared. And then we can also do the reciprocal functions. So inverse secant So that derivative is 1 over absolute value of x. And there's kind of a long story as to why that's absolute value. And if anybody wants to hear it, I can tell it to you, but I'm not going to do it right now because it's a long story. So 1 over absolute value of x square root. And note the difference here, x squared minus 1 as opposed to 1 minus x squared. Okay, careful with that. Inverse cosecant is the same thing but negative. It's a good question. I have gone both ways in the past. So no. So automatically that's the answer. I'll probably make you memorize these 3, but not these 3. It's kind of where I'm leaning right now. And notice the inverse cotangent is the same as inverse tangent, except it's negative. Okay, so can we apply the formulas correctly here? So let's try some examples of this. Going to be a lot of chain rule kind of stuff with this too, okay? But they shouldn't be too difficult, the chain rule ones. Some of them are a little more challenging than others, but we'll try a few together here just to kind of get the ball rolling. So let's say I have y equals the inverse cosine of the square root of x. Okay, so I'm going to have to apply this formula right here, right? But I'm going to have to do a chain rule with it, okay? And so I want us to start using the chain rule a little bit more now, not writing out the u equals and all of that, but to kind of see the structure of it from the outside. So you know you're going to have to use this derivative, and you know instead of x right here, it's going to be what? For this one, what should it be instead of just x in the formula right here? Square root of x. So you're going to make that substitution first, and then this entire fraction gets multiplied by the derivative of the square root of x. Okay? So start to think of the chain rule like that. Okay? So y prime is going to be that formula, negative 1 over square root of 1 minus the square root of x squared, and then that multiplied by the derivative of the square root of x, which is 1 over 2 square root x. And then for a lot of these, the real challenge is going to be simplifying the thing. You got a lot of square roots and squares and things like that that'll cancel, or if you multiply them certain ways, it, things break apart and that sort of thing. So negative 1 times 1, we've got negative 1. Now we've got this 2 square root x. I'm just going to put that in the front over here. And then we've got this other square root that is what? What should it be now? It's just 1 minus x, right? Okay, and so this one, this square root and this square root can multiply together. So we'll have negative 1 over 2 square root of x minus x squared. And there's really nothing more you can do with that. Okay? Yeah, you could take an x out of this thing, but then you'd be right back to where you were there. And so this is really about as simple as you can get it, or as far simplified as you can take that particular problem. Mm-hmm. Yep. Yeah, any two square roots can be multiplied together, right? So in this case, I've got one square root that's x, one square root that's 1 minus x, so I can distribute that together and it's fine. Yep. All right, let's try another one. How about y equals the inverse cosecant of 2x? Okay, again, it's a chain rule type thing, but I think you can handle that. All right, so find the cosecant one, and everywhere you see an x in that formula, now it should be what? 2x. And then you're going to multiply the entire works by what when you're done? Which is 2. So you should have 2x everywhere you see an x, and the whole thing should be multiplied by 2. Okay? So something like that then. Okay, and now there is still some simplification that can happen there. You can go ahead and square that 2x. And this 2 and this 2 here, those will still cancel, even though the one's in an absolute value. Anybody tell me why? What's the absolute value of 2? 2, right? So really, the absolute value of 2x is the same thing as 2 absolute value of x. It's doing the same thing, right? Because the absolute value of 2 is still just 2. So you can, in a sense, pull this 2 out of that absolute value, and then that will cancel this other one out. Okay? So our final derivative for this one then is negative 1 over the absolute value of x times the square root of 4x squared minus 1. Okay, so if we did that completely out, that would be it. So does that make sense what we just did there? Okay, all right. Let's see, what's another one we could do? The 4x squared? 2x times 2x. I just squared that together. The what? This one? This one canceled this one. I got this from the chain rule. Derivative of 2x is 2. This 2 canceled this 2. I got this 4 because I squared this 2. Okay. All right. Let's try another one here. Go to the next page here. Get this out of there. All right, so let's say, trying to find one here where we're going to have to do a lot of simplifying. All right, this one may or may not be part of your homework assignment, just saying. Something like that. 3 over t squared in our inverse sine. Okay? So it's going to do some strange things. So the derivative of inverse sine, we said was... I don't have that memorized offhand. Okay, so 1 over square root of 1 minus 3 over t squared squared, and then I got to multiply by the derivative of 3 over t squared, right? So what is the derivative of 3 over t squared? And if it's helpful, just remember this. So that's kind of where we're starting here, is we've got 1 over the square root of 1 minus 3 over t squared squared times negative 6t to the negative third. Okay, so see if you can follow me here. That's what I'm going to do. This negative 6 is going to come on up on top. I'm going to put a t to the third right here in front of the square root. Why am I doing that? It's t to the negative third, right? So I can put that down in the denominator. And then inside the square root, I've got 1 minus 9 over t to the fourth. That's just me squaring that thing. All right, I still got a fraction and a fraction, and I don't like that. So I'm going to work on getting rid of that. Okay, and here's where things get maybe a little off track from where you would think to go with it. I'm going to actually combine these two together. I'm going to make this subtraction. If I subtract two things where one of them is a fraction, what do I need to have? Okay, so keeping that in mind, here's where I'm going next. Okay, so instead of 1, t to the fourth over t to the fourth. And then if I actually do that subtraction now, I've got t to the fourth minus 9 over t to the fourth. And this is all, I should probably make this a little bit bigger here, but this is all under the square root, right? This whole big fraction. So again, it kind of seems like a situation where, like, why did I do that? Why am I making this look more complicated? Well, remember, when you square root a fraction, you square root the top and you square root the bottom, right? Square root of the top I can't do. It's a subtraction. I can't distribute a square root. The bottom I can. What's the square root of t to the fourth? T squared. Okay, so hang with me. We're almost done. So I've got negative 6 t to the third times the square root of t to the fourth minus 9 over t squared. So what can I do with that t squared now that I pulled it out of the square root? Everybody see it? What's going to happen? It wouldn't be t to the fifth. It would be just a t, right? Because this isn't a denominator, and this is not, as far as everything that's in the bottom. So yeah, you get a little cancellation happening with your t's there then. And so this derivative, all simplified up nice, is negative 6 over t times the square root of t to the fourth minus 9. That's it. Okay. And be very careful. It is a common mistake to say, oh, square root of t to the fourth minus 9, that's t squared minus 3. No. You cannot distribute a square root. Just like you can't distribute a square, you can't distribute a square root. Do not do the square root of both of those, even though they're just like begging to be taken. Don't do it. All right? That's it. You're done. So, okay. That's, I think, enough to get you guys rolling on this stuff. So tomorrow, you will have your online day where you can investigate this stuff a little bit further